Hello and welcome to section 8.3. Today we are going to look at the section that's titled the number e. Throughout the history of mathematics, there's been the discovery of special types of numbers all throughout. You have counting numbers, you have zero, they discovered negative numbers, there's numbers such as pi and imaginary numbers. Well, today we're going to look at one of the more famous modern type numbers, and it's kind of like pi and I, except we're going to look at what we call the number e. Now, e is also known as the natural base e, or the Euler number, and this is an irrational number. And because it is an irrational number, it is defined as the following. We're told that as n approaches a positive infinity, then 1 plus 1 divided by n raised to the nth power is going to approach e, which is approximately 2.7182. And you can see the rest of it. Now, if you want to look at this number on your calculator, you are going to have to hit the second button, and this is looking at a TI-83 or a TI-84. So you'll hit the blue second button, and then you're going to go down and hit the ln, which is your natural log button, and you'll see right above that ln button that you have a little e to the x. So on your calculator, it looks something like this. This is your natural base e number, and whenever you go to plug something into your calculator, this is the function that you're going to use. Now in this case, if you do that second and then e to the x button, on your screen, you're going to get e, and it's going to prompt you to type in something after that e. So you're going to want to type in a 1, and if you type in a 1, you're going to get that 2.718 number. Now when we're dealing with the natural base e, it's going to follow the same properties of exponents that we've been dealing with here in the last couple of sections. So when we look at example 1, we want to simplify. And just like when we've been dealing with exponents before, you can only simplify the like pieces of a fraction or a product and so on. So when we look at part A, we're going to simplify 24e to the 8th divided by 8e to the 5th. So I'm going to simplify the 24/8 first, and 24/8 will reduce down to 3. And then what you'll notice is we have an e to the 8th divided by an e to the 5th. Both of these have the same base, so if they have the same base and we are dividing, we are really going to subtract the exponents. So this is going to give me 3 times e to the 8 minus 5, or 3e to the 3rd. And unless it asks you to write it as a decimal, or round as so many places, you can leave it just like that. Now for part B, we have 2e to the negative 5x, and we're going to raise that whole thing to the negative second power. Now please don't forget, we actually have to distribute this power onto every piece inside of those parentheses. So this is going to give us 2 to the negative second times e. Now remember, when we have a power to a power, just like we do right here, we actually multiply our exponents. So this is going to give us e to the negative 5x times negative 2, or a positive 10x. And if I go to simplify now, you have a negative exponent right here with a 2, and that negative exponent is only on the 2, so that is the only piece that we have to move. So we end up with 2 squared, and e to the 10x is going to stay in my numerator. So again, I can simplify this in one more step, and we end up with e to the 10x divided by 4. And that's our final answer. Again, you do not have to plug that in your calculator, and actually you can't simplify e to the 10x anyways. Now the purpose behind example 2 is to give us some practice with our calculators. So please grab your TI-83 or TI-84, and we're going to evaluate e to the 3rd power. So what I'm going to do is I'm going to hit that second button, then I'm going to hit the capital L, capital N, which is your natural log button, and that will give you on your screen, it should give you an E and either something like this, or it will give you a little box to plug in your number, and in which case you're going to plug in a 3, close your parentheses, and hit enter. And when you do that, you should get something around 20.085, and on my screen it continues on, but you can round to 3 decimal places for now, and that should be sufficient. Likewise, we're going to do the same thing for part B. Now when I plug this into my calculator, I'm going to plug in E, and I'm going to do to the negative 0.12. And for this one, you're going to get something that's around 0.88, we'll say 7, or I have 8869. And we're going to leave it at the 3rd decimal place and move on. Now, if you're having trouble finding this button on your calculator, please make sure to ask me in class. Just like back in section 8.1 and 8.2, when we go to graph the function f of x equals ae to the rx, we're going to end up with something that either looks like an exponential growth function or an exponential decay function. Now, just by looking at the function and without having to graph this on your calculator, you can tell just by looking at your equation. And what you'll notice here is if your a value is positive, okay, which this has to be positive for both growth and decay, and if your r value or your exponent is greater than 0, or it's a positive number, then this automatically tells us that we're going to have an exponential growth function. So our curve then is going to look something like this. Likewise, if our a value is positive and our r value is negative, then we're going to end up with an exponential decay or curve that looks like this. And now if we think back to section 8.1, we looked at a formula that dealt with compounded interest. Now for our compounded interest, we were given that if a equals p, or a principal, times 1 plus r divided by n, remember r is our rate, n is our number of terms, raised to the power of n times t, and again t is time. We use this when we're compounding interest, like whether it be annually, quarterly, monthly, daily, and so on. Now, every once in a while you'll run across a case where you're going to be compounding your interest continuously. So if your interest is being compounded continuously, and that will be the key word. If it says continuously, you're going to use this formula right here, which a lot of people will call the PERT formula. You have your amount earned is equal to your principal times e to the rate times your time. And if it does not mention the word continuously, then you're going to use this formula here, because it's going to tell you that it's going to be 1 time a year or 4 times a year or whatever the case may be. You must know both of these formulas by the time you take your quiz or your test. These will not be given to you. So please take a minute to write these down and make sure that you have these somewhere where you will start to memorize them. So example 3 says that we deposit $1,500 into an account that pays 7% annual interest compounded continuously. So as you'll see right here, it does say continuously. We want to know how much is going to be in that account after 1 year. So we are going to use the A equals P E to the RT. So we're going to plug in our $1,500 for our P, E, and remember when we plug in our R value, we're going to have to plug that in as 0.075. You have to convert it to a decimal, and our time then is going to be 1 year. So when we plug this in, you should end up with something around $1,616.83. Now, just for comparison, it says, what would your balance be if your interest was being compounded quarterly at a rate of 7.5%? So here we're going to use the A equals P times 1 plus R divided by N to the power of NT, which means I have 1,500 times 1 plus 0.075. Quarterly means 4 times, and I'm going to raise that to the 4 times 1. So when I plug this in, I end up with a total of $1,615.71. So a little bit less than if you were to compound it continuously. Example 4 says that the atmospheric pressure measured in psi, or pounds per square inch, of an object that is d miles above sea level can be modeled by P equals 14.7 e to the negative 0.21 d. We're asked how much pressure per square inch would you experience at the summit of Mount Washington, which is 6,288 feet above sea level. So the first thing you have to take note on right here is that our distance here is given in 6,288 feet. However, we're told up here that D is miles above sea level. So we're going to have to convert that feet to an increment of miles. So there's 6,288 feet for every 5,280 feet in a mile. So what that's going to do is that's going to give us the fraction of a mile that 6,288 feet is, which should be a little bit over a mile. And when I do that, I end up with 131 divided by 110. That's the reduced fraction, which is about 1.190. But for the sake of typing it into your calculator, this here is probably going to be a little bit easier. So we're going to have P, or your pressure, is equal to 14.7 times e to the negative 0.21 times that 131 divided by 110. And when you simplify that and plug it all in, you should get something that was around 11.45 pounds per square inch, or psi. And the last example we're going to look at today deals with radioactive decay. And we're looking at radon-222, which is an isotope. It can be modeled by the function A equals CE to the negative 0.183 t. A is going to be our amount that is remaining. C is going to be the initial amount that we started with, and T is going to be the time in days. So part A says if there were 15 milligrams of radon-222 that was sealed in a glass tube, we want to know how much would be left after 8 days. So we're just going to go ahead and plug everything in. We start out with 15 milligrams, and we're going to multiply that by e to the negative 0.183 times 8 days. And when you plug that in, you should get something around 3.4, we'll say 7 milligrams. Now part B is just a little bit different. It says if 10 milligrams remain after 5 days, we want to know what our original amount was. So we're going to plug that 10 in for our A. We don't know what C is, but we do know the rest. We know E, we're going to raise that to the power of a negative 0.183, and we're going to multiply that by 5. So C then is going to be found by taking 10 and dividing it by that E value, or e to the negative 0.183 times 5. And when we simplify then, we end up with a value of C that is equal to somewhere around 24.8 milligrams. And again, if you have any questions on any of these examples, please make sure to write them down so that we can go over them in class. So on that note, I hope you guys have a great day, a good night, and I will see you later. Thanks.